Data modeling is an essential part of every successful data analysis. Welcome back to Excel Island, where we are trying to learn and master Microsoft Power BI over the next 100 days. Today is day 31. We've been so consistent learning over the past 30 days. And we're actually on a course called Data Modeling in Power BI, where the objective is to learn and understand how to build Snowflake and Star Schema data models. On the previous 3 live streams, when we started data modeling in Power BI, we've learned quite a lot, trying to understand the concept behind data modeling and the concept behind tables, breaking your measures, your details or your record into different tables, and actually joining those tables together to create a successful data model. Yesterday live stream, which was day 30, we learned all about creating star schema data model. In today's live stream, we will learn how to create what is called the Snowflake schema data model. So without further ado, let's get back to learning. So if you're new to the channel, you can catch previous lessons, previous live stream on the channel, or you can go to the live stream tab on the channel. You can catch the latest live stream that we've covered so far. Also, all the task set exercise files, Power BI files that we'll be using so far the last 31 days, yes, the last 30 days is already linked under the YouTube description. I will make sure to be consistent with that link. That's where you find all the old files we'll be using over the next 100 days. So without further ado, let's get back to learning Power BI and upskilling ourselves. Welcome back to day 31. So I'm actually using the DataCamp platform. Currently subscribed to a 1-year subscription on the platform, and we are on the next course. This actual course is data modeling in Power BI. If I show you what the career track look like, we are trying to take a whole career track on Power BI, trying to understand all the rudiments, all the tools, all the whatever you need to understand with Power BI, and make sure you understand the tool fully well. And we're actually on the career track called Data Analyst in Power BI, which actually contains 17 courses estimated for 42 hours or probably 45 hours. So we're actually on the 7th course right now. Yeah, we're on the 7th course. And actually, I started this whole idea from data analysis in SQL. If you're looking to learn 1 or 2 things in SQL, do watch previous lesson on the channel also where we covered SQL for 100 days. And we're actually on data analysis in Power BI right now. We are 39% throughout the whole career track, and today is day 31. That means we are moving at a good pace. Also, after completing the data analysis in Power BI, the goal is to start the data analysis in Python career track also for another 100 days. Probably throughout this year, I'll be using this year to upskill myself and all my skills in the data world. So do make sure to subscribe to the channel right now. Put on the bell so you know whenever I go live or drop a new content on the channel. So I click on data analysis in Power BI. Let's see what that looks like. You can see 17 courses estimated for 48 hours. And we covered quite a lot, all the way from introduction to Power BI to data transformation in Power BI. We're actually on this data model in Power BI. And we're on the last chapter in the course, which is Snowflake schemas. So without further ado, that's all we've been up to so far. I will just continue from where we stop on day 30. So let's continue the course and learn all about Snowflake schemas in Power BI. So you can see that we've covered defining tables, shaping tables, dimensional modeling. So we want to work on Snowflake Star and Snowflake schema in depth right now.
Welcome back. Let's continue building on your knowledge from earlier. In this video, we'll take a look at Snowflake schemas, an extension of the star schema. Remember from earlier that a star schema consists of 1 or more fact tables surrounded by dimension tables. The Snowflake schema is like a star schema, except it allows relationships between dimensions. In the example, you can see that the lender and property dimensions each link to other dimension tables. Note that fact tables remain the same. The biggest difference between the two styles is how they handle hierarchical data. Star dimensions tend to have all levels of a hierarchy in the same table, whereas with Snowflake dimensions, hierarchy levels are explicitly broken out into multiple tables. Here you can see a product dimension table. Imagine that each product has a name. Each product also belongs to a product subcategory, which itself belongs to a product category. In a star schema, all levels of the hierarchy, as well as their attributes, show up on the same product dimension. With a snowflake schema, each level of the hierarchy becomes its own table, and we join those tables, usually with keys. When it comes to dimensional modeling theory, we strongly prefer star schemas over snowflake schemas. The key reason is that star schemas are easier for business users to understand. They don't want to worry about the keys or hierarchies. The other benefit is that quite a few business intelligence tools have been optimized for the star schemas. Although dimensional modeling theory leans heavily towards star schemas, we do see snowflake schemas in some data warehouses. The reason for this is that star schemas duplicate quite a bit of data, which leads to storage costs and can impact performance. Also, star schemas are not ideal for frequently updated data, especially with large dimensions. Suppose you have millions of rows in a dimension containing a column for a country. When a country name changes, you may have to update a large number of rows with the new country name. By contrast, with a snowflake schema, this would be an update of a single row. When it comes to Power BI in particular, it is important to note that both schemas work. If you have a snowflake schema in an existing warehouse, you could import the data as is, making migrations easier. That said, Power BI does prefer star schemas for the same reason as dimensional modeling theory, because it's easier for users to understand. Furthermore, there are some optimizations in Power BI which make performance much less of a concern. Power BI has a built-in performance analyzer. When enabled, it keeps track of at least 3 key measures on each visual. The first is how long it took to read the data from its internal database and then perform any DAX operations on the data. The second component is figuring out how long it took the visual to render. Finally, a third measure captures everything else, which is typically waiting times on other operations, including waiting for cross-filtering operations to complete. There are a number of ways you can improve performance. If the DAX query takes a long time to complete, you could tune your DAX operations or improve your data loading performance. This might include improving your data model. If the big problem is in visual display, use less complicated visuals and show less information on the screen. Power BI needs to render each data point, so plotting tens of thousands of points may take a while. If the other value is the cause of your slowness, you might want to reduce the number of visuals on the page. Time to practice!
Alright, so I think we quite understand the difference between a star schema and a snowflake schema, and Power BI usually prefer, or most business owners prefer star schema. I'm quite used to star schema, but I think I've practiced a couple of snowflake before. So having a solid understanding of the difference between star and snowflake schemas is an important precursor to deciding which model works better with a given technology. So which of the following would you expect to see on a snowflake schema but not a star schema? Okay, a fact table joining to another fact table? No. A fact table joining to a dimension table joining to another dimension table. So you join dimensions in a snowflake schema, you join dimensions to each other, dimension connects to each other more than star schema. So that's correct. So this is exactly what distinguishes snowflake schemas from star schemas. A snowflake schema is essentially an extension of a star schema where each dimension can be connected to one or more dimensions as well. So that is the major difference. It's just an extension.
In this demo, we'll see how to create a snowflake schema and learn how to use a performance analyzer. Here in the model view, you can see the star schema I created earlier. If we take a closer look at the geography dimension, we can see that it is made up of hierarchical data. Country first, then state. One of the main differences between star and snowflake schemas is how they handle hierarchical data. Since in a snowflake schema dimensions can be connected to other dimensions, we can split out the state and country information. Let's do exactly that. I'll go into Power Query by clicking Transform Data. I'll duplicate the geography table twice and rename the new tables Country and State. Let's think about how we want to connect to the fact table. The most detailed level of geography is state, and that is also the ID that is present in the fact table. So we'll connect the state table to establishment survey. We'll also need to connect the state table to the country table, which means we need to keep the country ID as well. But the actual country value can be removed here. I'll right-click and select Remove. Next, we'll look at the country table. This one should contain only country information, so I'll remove all state data. Let's also remove the duplicate rows. Looks like there is only one country in our data at the moment. Note that if the country value would have to be updated, we only have to do it in one place in this snowflake schema, whereas it would be a lot more cumbersome to do this in the star schema from before. Let's close and apply and take a look at the data model. Note that I've kept the geography star dimension as well, so we can easily compare performance later on. In a real-life situation, you would use only one of the two approaches. You can see that Power BI has automatically created relationships between the star dimension and the snowflake dimensions. This is not right. Let's remove them. I'll right-click on the line and select Delete. Let's do the same for the other table. There we go. So these are our snowflake dimensions. Now I'm going to create a relationship between the fact and state tables. I could drag the column names on top of each other or use the Manage Relationships button here. I'll select New and choose the two tables. You can see that Power BI has recognized state ID as the key, which is correct. Click OK and close. Lastly, you can see that the relationship between state and country is a dotted line, which means it's inactive. Let's quickly change that by going into Properties. There we go. That's our snowflake schema. And this would be our star schema. I'm going to go into the report view and create two visualizations. First, I'll create a bar chart with the number of establishments by state, using the field from the star dimension. Then, I'll do the same, but use the snowflake dimension for the state. Let's quickly rename these visuals to star schema and snowflake schema. Now we can compare the performance. I'll go to View here at the top and click on Performance Analyzer. This pops out the Performance Analyzer pane. I'll start recording and then refresh the visuals. This will show me the time it takes to load the two visuals on the page in milliseconds. If I refresh a couple of times, we can see that one schema isn't consistently faster than the other. With our small dataset, everything loads pretty quickly. But if you're working with thousands or even millions of rows, the star schema should be more efficient. This is because star schemas will only join the fact table with the dimension tables, leading to faster execution times. That's it. Time for some exercises.
That's quite interesting. So you can see that using star schema is much more better than using snowflake. So let's do some exercises and get around this. We want to create a star schema, we will create a snowflake schema, we'll use the performance analyzer, to see the performance of both schemas, then that will be the end of the data modeling part of the course. Okay, so I think this is what we stopped yesterday. I've actually loaded the file I was using yesterday. Probably I need to load star schema Power BI file. So let me just load that file real quick. So star schema. So right as it's coming up, so if you lost any progress, close any open reports and load star schema from the exercise file. So the instruction is to create a new page and name it Industry Insights and navigate to the data view to get familiar with the columns in the industry dimension. Okay, let's see. Let's look at, we have both of them here. But if I need to go to this and point to each data set. Probably I could still make use of my old file just to save time. Age, establishment, industry, and time. Let me just make use of my old file here. Since we are still using same data sets for the exercise. Create a new page and name it Industry Insight and navigate to the data view to get familiar with the columns in the industry dimension. Okay, so I'll just make use of my data set from yesterday, that is the 30. Let's call this page Industry Insights. So you could see our data model right here. This is a star schema that we created from yesterday. You can see all our dimension table are connected to the facts table, which is this one here. So, but let's follow the instruction and see first. So create a new page, name it Industry Insight, and navigate the data view to get familiar with the columns in the industry dimension. So the industry dimension, this is our industry table. With the columns, we have the code, the industry code, the industry description, the industry group code, the industry group, subsector code, subsector, and sector code and sector. I think you can just navigate back and forth if you are confused. So in the report view, add a table visualization with the following columns from the industry dimension. So let's add the table dimension here. This is a table. In our table, we want to add these columns. We want to add the industry group, the code description, sector, or subsector. We want to add the industry group. That's that. And then I say code description. That is sector and subsector. We got sector and subsector. So you can see the data set is wild. I can just hide all of this. So I'm not able to see the whole information. How can we do that? We can just move, can see. We have the 4 columns already added. So let's follow the instruction. It now says, note that the columns in the industry table make up a hierarchy. Starting from the highest level, each category gives a more granular view of what industry the establishment operates. Each category. Okay, so let's see the category. Okay. It gives us more information about where this subsector, okay, where the industry, this industry, this plastic and rubber, this first table here is giving us more information about where they work. So if you just follow the instruction, Put the columns in the right order, going from less to more detail. Okay, let me read that again. Note that the columns in the industry table make up a hierarchy make up a hierarchy starting from the highest level. Each category gives a more granular view of what industry the establishments operate in. Okay, it now says put the columns in the right order, going from less to more. Okay, from less to more, we could just arrange that. Let's see. I think we're supposed to start with from less. I want to go from less to more. That means from the lowest to the highest. So if we just say the sector should be here. We could just get the subsector up right here. Then we should have the subsector should be right here. Sector, so from less to more. Okay. Then from which one should come first? This industry group should be the next one here. So from the description, we have the industry, we have the subsector, then we have the sector. Let's see. So how is the industry hierarchy structured? Let's see whether we got it. Sector, subsector, code description, industry group. Let me see. From less to more. Oh, I should go from sector to subsector. Okay, let's see. I think this. Oh, the the column at the lowest level of the hierarchy should have a unique value for every row. So I'm looking for a column that have the unique value for every row. Let me see. Lowest level. This is the lowest level, right? Say the lowest level. Okay, from less to more. We're going from less, that is from lowest to highest. So you are saying from less to more means from highest to lowest. That doesn't make sense. Let me take a look. Probably it should be okay. This industry group. Let's see here. I said the industry group should be the first one. Industry group, the description of the industry group, the subsector and sector. Okay. Instead of saying sector and subsector, it should be the sector first. This is sector, subsector, industry group. Okay, let me take a look at that. The sector, subsector, that means from more to less, yeah? Sector, subsector, then the industry group, then the code description. Exactly. So this code description should be the last one here. If you're saying from less to more, this is from less to more. That makes sense. From the lowest to the highest. Oh, interesting. That means from the lowest to the highest. Sector, subsector, industry group, and the description. And the sector is greater than the subsector. Oh, the subsector is greater than the industry group. Then the industry group is greater than the code description. That is definitely from less to more. Well understood now. We're just building a simple hierarchy. Fantastic. In a star schema, hierarchical data is always stored in one dimension. So let's take a look at how we can use a snowflake schema to model the industry data. Let's create a snowflake schema here. Now we'll be grouping the sector, subsector, industry group, and the code description into different tables. But we are using a star schema. We can just have all of them in one table, like we have in the industry table here. Interesting. But for a snowflake, we'll be having 4 more tables. You can see 4 more tables. That's quite funny. So let's give this a shot. I think that is the next one there. So note that in this exercise, we also keep the stars dimension so that we can compare the results. In real life, you will use one of these two approaches. Okay. So you say why Power BI is optimized for star schemas. It needs to work in a variety of use cases. One alternative data modeling approach is to use snowflake schemas where dimensions can be connected to other dimensions. A big difference between the two is how they handle hierarchical data. Star dimensions tend to have all levels of the hierarchy in the same table, just like we showed here. While with snowflake dimensions, hierarchy levels are broken out into multiple tables. So we want to create something like this. So go to the Power Query and duplicate the industry queries 4 times. Definitely 4 times, because we need to have 4 tables for the code description. This code description will be connected to the industry group via the nice code. Then this industry group will be connected to the subsector via the industry group code. Then this subsector will be connected to the sector via the subsector key or code. So we have to go to the tab here to our data model Power Query view and duplicate this 4 times. That's funny. Queries 4 times. Okay, 4 times. Duplicates, then duplicates. We still need to have the industry table. Yes, we still need to have the industry table right there. 2, 3, 4. Oh, this is 4. I think this is 4. 1, 2, 3, 4. Yeah, that is 4. Next is knowing the hierarchy as sector, subsector, and industry group and next code. For each table, keep only the code and text description column corresponding to that level of the hierarchy, and also keep the code of the next level in the hierarchy. If there is one, make sure to remove duplicates. So let's take a look. Well, we need to start with the sector, subsector, industry group. We can start with this nice code description. I'm going to do it like this. The first one is going to be, I need to do something like this. Industry 1, industry 2. Okay, I want to make sure they are beside each other so it is well understood. Can't I arrange them? Or I can arrange them. So I want to make sure they are just beside each other here so we can understand what we are doing. So the first one is our, let's see, is our sector. We want to have this one as the sector and the sector code. We're going to have the sector and sector code here, while the subsector, okay, let's take a look. Knowing the hierarchy as sector, subsector, industry group, and the code description. For each table, keep only the code and text description columns corresponding to that level of the hierarchy. Also keep the code of the next level in the hierarchy. If there is one, make sure to remove duplicate. So let's see. So let's do it gently. So I'm going to start from the code description. Okay, let's start from the code description. So this is the code description here. So I just select this, and remove other column. Okay, let me just remove other column. Remove other columns. So we have a nice code and the code description. So with that, we need to go to the industry group. This is going to be, I can just rename this one as NAIC. So let's just name it like that first. So I think that's the first one here. If I go back to my context, this is the NAIC code here. So the next one is the industry group. The next table. So our next table here should be the industry group. So I need to make sure I'm keeping this NAIC code here. I'm going to use the code right here to connect to this one right here. So this code here should be one has to be unique. This code here has to be unique, if I'm not mistaken. Let me see. Let's see if we can remove duplicates. Oh, there are no duplicates there. So just 10 rows. Let me just delete. These are just things. So this is unique. So the next one is the industry group. So the industry group. I need to make sure I'm keeping this code. So I'm going to remove this column. Industry group. Let me just bring this here. Industry group code. Then the industry. So if I have these two locked in, all I have to do is just remove other columns. Remove other columns. So I have this three table here, which is the industry group. So I can call it industry group. These are industry group. So are there any duplicates here? I doubt. Let me try to remove duplicates first. They are just 10 rows, so there are no duplicates there. Let's see. So that means in a snowflake schema, each table is unique. So each record there is unique. So why the next one? So I'm going to use this code here to connect to this one here. That's the industry group. Why the next table I want to create is the subsector. So I need to make sure I'm keeping this industry group code right here. So I'll need this industry group code. I can just allow it to be here. Let me go back here. So I can just make sure that this one is the last one here. So to make sense. So this is our industry group code, the industry description, and this column to connect to this table here. So if I come back to this subsector, so my first table should be my subsector code, which is this one here. I can just, there's a way to move to beginning. So my subsector code, then I also have my subsector right here. I can just quickly move it. Or let me just drag it to the right side. So my subsector is going to be here. Then I need to have this industry group code here. I'll just name this table subsector. Subsector. So we're trying to build a snowflake schema. So subsector code, subsector, then this industry group code is going to be right here. So right now I can just remove other columns. Remove other columns. So I'm going to use this subsector industry group code here to connect to this industry table here. So the last one is going to be my sector table. So this is going to be sector. So for the sector, we need to have the sector, subsector code, then the subsector code. So I could just remove, let me just bring this right here. So I could just quickly select these three tables. No, I'll remove other columns. So I'm left with my sector code, the sector, and the subsector code. So I'm going to use this subsector code to connect to this sector subsector table. I think we are done. Definitely nice building that real quick. So sector, subsector, industry group. So we follow the instruction that says for each table, keep only the code and text. For each table, keep only the code and text. Only the code and text. I'm actually keeping 3 columns. I'm going to only keep 2 columns. So for each table, keep only the code and text description columns corresponding to that level of the hierarchy, and also keep the code of the next level. Right? So I'm correct. So and also keep the code of the next level in the hierarchy. So I have to make sure I'm keeping 3 columns. So that's absolutely correct. So remove duplicate. So there are no duplicates. Oh, I think there are duplicates here. If I try to remove duplicates here, there are duplicates right here in this table. So let me see. Let me see if it's going to remove duplicates. Aha. Let me remove duplicates first. There are 10 here. So here there are duplicates. I need to make sure there are no duplicates right here. As you can see, so the sector code has to be unique in this place. Why the subsector here? Are there duplicates right here? Remove duplicates. Yeah, there are duplicates here. So I need to make sure I'm removing duplicates because each record has to be unique. Let me see right here too. Remove duplicates. There are none here. What about this table here? There are none here. So I think we're on track. Close the Power Query and go to the model view. So let's close the Power Query right now. Close and apply. And we go to the model view. So it's applying our changes. Oops. So I can just delete this one here. So let's go to the model view. So it's going to automatically create, you can see, it has automatically creates hierarchy for us, which can be wrong sometimes. Oh, absolutely wrong. You can see it's supposed to be the code. It's supposed to be this table connected to this table, then this subsector connected to this. I'm trying to arrange them the way it's supposed to be. Then subsector, then sector. It started to make sense now. So it's bidirectional. So I just have to delete all the, it says delete the automatically created relationship between the industry star dimension and the 4 tables we just created. So we need to delete this. I need to make sure I delete this. Select connection, delete, do that our delete, delete. So we have to make sure we understand all this before we can start connecting them together. So if for some reason a new table is not showing up in the model, we can manually add a relationship using the manage relationship icon. Okay. Create a relationship between nice code and establishment survey. So we need to create a relationship between this and this establishment survey. So how to do that? We're going to use this code description here, this code. So I can drag from, it is many here. Definitely it is, they are not unique here. The only thing that is unique here is the ID right here. I just drag from many side to the, that is from foreign to primary. You can see this is many to one. So this is many to one relationship. Or probably some people say one to one, many to one, or one to many relationship. You can see that this nice code here, they are actually not unique, while this one here, they are unique. So that's that. So that's the first relationship you need to create. So the next relationship, so you can zoom in and out of the data model by using the plus sign in the bottom right of the Power BI button. So you can see we've gotten that. If some reason a new table is not showing up, model view, you can do that. So we know how to do that already. So check that the other snowflake dimension are connected to each other in the right order. If they are dotted line relationship, double click on the relationship to go into the properties and select make the relationship active. So we need to now connect from this. This will now connect to this. This is our industry group code here. So our nice code description is there. So nice code description, which is right here. Now connect this to this. This is going to be one to one. That's because there are unique record there. And this is going to be from the industry group code to this. Wow, why is it saying one to many? Nope, it's not supposed to be one to many though. Let me now see the subsector. Let me go from here, from the industry group code, which is this, to this here. Oh, now one to many can see. So from the many side, but the industry group here, let me just quickly see that. The industry group table should be unique. Okay, this won't be unique. The code here won't be unique. Only the code here should be unique. So there's possibility of having duplicates here. 315220. Okay. Then the last one is to go from subsector, which is this code here. This is this many sector code. This one will actually be unique. But we need to go from this to this. Let's see. Yeah, one to many. So that's how you create you can see we are connecting the dimension table to each other. So from this to this to this to this. Okay, that's quite tough to do, but if you have a good understanding of what is happening there, you could sort it out. So now say find the hierarchical level, the table that contains food manufacturing, and tell how many rows would you have to change the name of the subsector changes. Find the hierarchical level table that contains food manufacturing and tell how many rows would you have to change if the name of the subsector changes. Oh, the question is not okay. Check that other snowflake dimensions are connected to each other in the right order. If they are dotted line relationship, double click on the relationship to go to the properties and select make this relationship active. So we've done that. But let's see the question. Find the hierarchical level table that contains food manufacturing. Okay, let's try to find that. Hierarchical level table that contains food manufacturing. Oh, let's see. So let's begin the table. It says the instruction says find the hierarchical level table that contains food manufacturing. Food manufacturing. Let's see. So just the code. Okay. Subsector. Industry group. So the instruction says, find the hierarchical level table that contains food manufacturing. Okay, so let's go back to the table. Okay, if I go to the sector, subsector, food manufacturing, so we could go to the subsector and drop that in. Let's go to the subsector. Okay, industry group. Okay, so now says find the hierarchical level table that contains food manufacturing and tell how many rows would you have to change if the name of the subsector changes. Food manufacturing 1, 2. I think that's just 2 rows. So this is the subsector. Let's see. So if that's not right, if you are using the industry star schema dimension, you have to change the value in two places. But updating values in the snowflake schema is more efficient. Okay. Oh. I've actually deleted. That's what we created earlier. I deleted that what we created earlier. So let me just undo it. What we did that time, we used okay, we actually dissolve this table, so we can't do that again. So I'm trying to actually create what we did earlier then, but we started with, okay, let me see what we started with then. Street group, okay. So we started with the nice code, then the industry group, subsector, and sector this time around. Let's see. So this is what we created earlier. So we see about, because this table, they are connected to each other. So it now says we should find the what? Find the hierarchical level table that contains food manufacturing and tell how many rows would you have to change if the name of the subsector changes. Find the hierarchical level that contains food manufacturing. Oh, the question is tricky. Okay, we have food manufacturing here. The question is quite tricky, and I can't seem to figure it out. Okay, let's take a hint. In the snowflake schema, we connect multiple tables with keys instead of fully describing a hierarchy in a single table. With this in mind, you can go to the data view, look at the subsector table, and count how many times does manufacturing appear. That's exactly what I did. So how many times does manufacturing appear? So in the snowflake schema, we connected multiple tables with key instead of fully describing a hierarchy in a single table. So with this in mind, you can go to the data view. Okay, let me follow the instruction. Data view. Go to the data view, look at the subsector table. I'm actually on the subsector table, and count how many times does food manufacturing appear. Food manufacturing only appeared twice. I was guessing that correctly earlier. 1, 2. Food manufacturing only appeared twice. So what's the error there? Oh, so food manufacturing appeared twice. You can see food manufacturing 1, 2. It says food manufacturing. You have to say change to rows. Let's look at the answer. Solution 1 Why is it 1? Oh, so food manufacturing appeared in the subsector table. It appeared twice. Oh, it's supposed to be 1. So that means I didn't remove duplicates correctly. So it's supposed to be 1. That means I didn't remove my duplicates correctly. You can see the subsector code is the same thing. 1, 1, which it's actually supposed to be unique. So let me go back to my data set here. So I was right on track. I didn't just remove the duplicate. Let me look at the subsector. I actually remove duplicate from here. Oh, okay. So also remove duplicates. Okay, let me just cancel this and say remove duplicate right now. Then it should be 8. My mistake was using, okay, if I remove duplicate right from here, this is 10. Remove duplicates is 9. So the code here has to be unique. Subsector, sector, because I have 31 here. And I actually removed duplicate earlier, which is 10, but it's supposed to be unique. So the sector is, there are just 3 sector code 31, 32, 33. The subsector. So my mistake earlier was not moving the duplicate correctly. I didn't even pay attention to it. Interesting. So what I need to pay attention to is when creating a snowflake schema, let's look at the industry also. I actually removed duplicate earlier, but I removed duplicates from the 3 table instead of the industry code table. This is still 9. So each of them here has to be unique. Okay. Okay. So if I go back, let me apply. So if I should go back to my data model, let me see. Oh, we can see something is missing here. Food manufacturing actually appear once. So let's look at the data model view. So it's still showing 1 to 1 to 1, 1 to 1 here, which is bidirectional. If I delete this, this is 1 to many, 1 to many. It's supposed to be, okay, let me delete this first. Let me delete this first. I'm just trying it again. So from the many side to this, let's see. You can see many, 1 to many. And from this side to this saying 1 to 1. And that's definitely because the record there is unique. That's quite interesting. I need to troubleshoot understanding this snowflake schema a little bit more. So let's look at the performance analyzer so we can just go and practice behind the scene. So in this chapter, you've modeled the industry data into 2 different ways, a star schema and a snowflake schema. Let's compare the performance between the 2 approaches. Power BI Performance Analyzer provides a mechanism for measuring performance in Power BI. It looks at the speed of data retrieval, DAX operation, and display of information on the screen. Although the visual and data set we work with are fairly simple and will load quickly, and we can still use these values to understand the tool's potential. So I'm quite curious to understand this a little bit more. Oh, back to report view. So let's remove this and just follow the instruction here. So go to the report view and create a new page named comparison. Create a line chart with the decade on the x-axis. So let's create a line chart first. A line chart. Let's see if we can make that happen. Create a line chart with the decade on the x-axis, the average number of employees on the y-axis. So decade on the x-axis. Oh, that should be time. Decade and number of employees. So we could see that number of employees by decade, but we want the average number of employee. So create a line chart with the decade on the x-axis, the average number of employees on the y-axis. So I could just change the calculation here from sum to average. That makes sense now. Okay. So it now says from the star dimension industry on the legend. From the star dimension. So that is star schema. So I use the star schema here. Okay, it says create a line chart with the decade on the x-axis, the average number of employees on the y-axis, and the subsector from the star dimension. Okay, I need to add a subsector from the star dimension industry on the legends. So I need to add the legend. Let me look at the industry. Subsector. I need to get a subsector from the star dimension. But that will be pretty hard to do because we don't have any star schema here again. If I go to the subsector, if I add it to the legend, ooh, you can see it just scattered everything. I don't think that is what we want to do. Let's continue first. The average number of employees on the y-axis and subsector. Let me see. Ooh, let's see. Create another line chart with the decade on the x-axis and the average number of employees on the y-axis and the subsector from the snowflake dimension on the legend. So I need to add a subsector to the legend, but I need to make sure I'm adding a subsector from the star dimension and a subsector from the snowflake dimension. So how do we do that? Okay, now let's look at this. So for the legend, if I go to the model view, we don't have we don't have subsector here. There's no record for subsector here. Except I have those records here, I can't make use of it. That's quite interesting. Oh, I need to try this question again. So let's just give it a shot and see. So the first one says average number of employees on the y-axis and the subsector from the star dimension. Because I don't have access to this is star dimension, this is star schema here, these three tables here, but I don't have access to the subsector right here. The subsector right here. Probably I need to watch the way she did it earlier. So I don't have access. So the subsector is added to the legend. So it's actually added to the legend, but I just scattered the charts, not making sense. But let's do it again. I can't actually guess, but this is not from the star dimension, this is from the snowflake dimension. Because okay, let me see if I can just peep that out right from here. I won't be able to do that because I can't actually connect this table directly to the subsector code. I can actually use that. Let me see. Let me see if I can use the subsector code here. Hmm. No, it's supposed to be in the legend. it is still in the legend, but it is not showing the codes, which is still almost the same thing it is showing. But let's leave that part. I'll probably need to try it again of the live stream. We spent quite an hour trying to figure this out, right? Probably because it's the first time. Okay, so I don't have any dark query there. So I'm just guessing it will be the others. So where the visual quite displayed very well. So performance seems like waiting time on another operation, including waiting for cost filtering operations to complete takes the longest. Now that Note that there isn't a big difference in performance between the two schemas here. Once you move to a bigger data set, the star schema should be much more efficient. But that's interesting. I probably need to try it off live stream just to see what is happening here. Definitely be watching. We try to watch what she did earlier again.
Congratulations on reaching the end of this course, and thanks for taking it. Hopefully, you have a much better understanding of data modeling in Power BI. In the first chapter, you learned more about the basic concepts of data modeling. After that, you saw how to load and transform data from multiple sources with Power BI and Power Query. By the end, you also mastered how to merge and append tables. After that, we moved on and studied one of the most popular approaches to data modeling. You learned all about the basic building blocks of the dimensional model: facts, dimensions, and star schemas. After that, we continued with an extension of the star schema, the snowflake schema. Once again, thank you for taking this course. We wish you the best of luck with your future Power BI analyses.
All right, thank you. I think I'll probably just be sticking to my star schema data modeling. Display schema is kind of a little bit complicated, but you have to try over and over again, then it starts making sense. So the next course should be, our next course should be, let's see, intermediate data modeling. We are taking the data modeling part a little bit advanced. And so really need to do that. Intermediate data modeling, that's quite interesting. Granularity measures and hierarchies. Advanced modeling, then identifying performance problems. I'm looking forward to this part of the course because data modeling is quite wide. So we'll continue from here on day 32. Alright, so thanks for staying to the end of the live stream. So if you found value in this video, trying to learn and master the Power BI tool, do well to support the channel by giving this video a thumbs up, hit that subscribe button so you know whenever I drop a new content or go live on the channel. And I'll see you on day 32. Do well to download those data set exercise files so you can practice and improve your Power BI skill also, like I am doing. Bye for now. Thanks for staying to the end of the end. Have a wonderful rest of